All right, we are going to take a look at a problem and work through some of the steps for solving this problem. And as is usual in mathematics, there is more than one way to get to an answer here. We're going to start out with a given. We get a pattern here. We start out with A. When we move to B, we add B's on either side. When we go to C, we add more. And so we get this kind of triangular pattern. Now, if you are familiar enough with mathematics to know about triangle numbers, you might at first think that this is just the triangle number pattern, but it's actually one off because the pattern should be 1, 3, and then it's going to go from there. So this already is off because there's 4 numbers that would be here with this pattern because we have 1 and then plus 3 more gives us 4. So this is not the triangle pattern. So if you were familiar with that you might be going right for that as your first guess, but that's not what we have here. What we have is one off, as I said, so this is a pattern that continues on, and we have a couple questions we are going to try to answer based on this pattern. So with the ellipsis here, we know that this pattern continues. The next column will be D, and so we have 5 C's here, so we're going to end up with 6 D's here. No, 7 D's here. So because we add 1 on each side, 1 more than this, so we're adding 2. And so we had 5, we're going to end up with 7. Okay, so we want to know how many letters will be in the R column. So if we continue this pattern out, how many are going to be in R? So one way that you could do this is by just brute force and just list all these out. But that's not what we want to do. We want to use the technique of patterns. And so that's what we're looking for. The other question is, which letter will be repeated 23 times? So at some point, there's the assumption that we will eventually have a column with 23 letters. Which letter represents the column that has 23 repetitions of that letter? So these are two questions here, slightly different approaches to answer each of these. But first of all, we want to establish the pattern. So I want to look at in this column, I'm going to designate these with a subscript notation, and I'm going to create what I'm anticipating is an arithmetic sequence. So in my first column, I have 1 term. In my second column of the alphabet, I have 3 terms. In my third column of this, I have 5. And so what kind of a pattern can I see here? Well, if I look at this, I have 1, I have 3, I have 5. So this looks like the odd numbers. So I am anticipating that my 4th term is going to be 7. And so I can just by filling in here, we can see if we can complete that pattern here. So D would be here, 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 and then 1 more, here, here, and then 1 more. So do I have 7 here? 1, 2, 3, 4, 5, 6, 7. Yes, 7 fits the pattern. So if this is really an arithmetic sequence, we can use that formula to find any of these letters, how many letters are repeated in any column in this sequence, if we know this formula. So this is the formula for an arithmetic sequence. The first term in your sequence, n, is going to be the number of the column that we're looking for. So this I designated as 1, this one was 2, this one's 3, this one's 4. So we can use this. So then what it ends up being is, if we want to know which letter is repeated 23 times, that's going to be our n value here. So that's going to be helpful in solving this. So how many letters are going to be in the R column? So to figure that out, we've got to kind of convert R into a number. And so R is the 18th letter of the alphabet. So this is the 18th column. So that's going to be important for us in using this formula also. So right now, let me take this. This is just the formula. I need to write the equation that I need to that describes this sequence, and then we can start trying to solve for this. So I need to substitute some things in. A sub 1 is over here, so we have 1. We don't know n yet because we're doing the general case. And d is the difference between each term. So what's the difference between here to here, here to here, and here to here? It's 2. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So this is 2. So this is going to be the nth term. So I just need to simplify this. So this is basic algebra. This is distribution property from the right. So this comes in here and multiplies by the n and also by this 1. So I have this, and then I need to simplify. I have this integer value, this integer that can be combined. So I have 2n minus 1 is going to be the nth term. So right now let's solve this first question. At the 18th column, and each of these subscripts represented a column, the 18th column is going to tell me how many repetitions of R I have here when I solve this. So I want A sub 18. I want the 18th column. So I put in the 18 for the n over here also, because I replaced n here with 18. I'm replacing n here with 18 to be consistent. This is coming off of this formula here that we derived for this sequence. And then I'm going to subtract 1. So 2 times 18, that gives me 36 minus 1, that gives me 35. So in the R column, there's 35 letters. So R is repeated 35 times. So looking down here at which letter will be repeated 23 times, since 35 is larger than 23, we know that this is going to be some letter prior to R. So somewhere between A and R, a letter repeats 23 times, and we're going to try to find that. So the answer to this question is 23. All right, that's our final answer here. So now we need, no, I'm thinking of this question, 35. That's the answer to this question based on this formula. All right, so now I want to know 23 times. So in this next case, I'm going to replace the A sub n with a 23. Over here, the final number here was the number of times a letter was repeated, 35 in this case. So now to answer this question, I'm going to replace this A sub n with 23. And then I'm looking at 2n minus 1 here. So I'm going to solve this for n. That is the only thing that I don't know at this point. So this is another algebra step. So I have equal sign here. Everything I do to the right side, I'm going to do to the left-hand side. So I'm trying to get n by itself. So I'm going to continuously apply inverse operations until n is by itself. So the opposite of subtraction is addition. So I'm going to add a 1 to both sides. So I have 24 equals 2n. And since I have multiplication here, I'm going to divide by 2. And so I have 12 equals n. So I'm looking for the 12th column, because remember, n represents which column that we started with up here, because each subscript represented one of these columns. So I'm really down to the question now. of what is the 12th letter of the alphabet. If I find which one is the 12th letter of the alphabet, I will have answered the question, which letter is repeated 23 times, because it's going to occur in the 12th column. Alright, so I have written out the alphabet here through O, and we find that L is the 12th letter. So L is going to be repeated 23 times. And again, you could complete this pattern out until you get the L and count it, and you should find that it is 23 times that you write down the letter L. And so we have used arithmetic sequence to find a solution to this. All right, so there are other ways that you could solve this problem, but we've applied this idea of a pattern that we've determined here, designated each column with a certain number. We created this arithmetic sequence, got a general formula, which is somewhat of a recursive formula, and we were able to solve these two questions that we started out with. How many letters will be in the R column? There's going to be 35. It's R repeated 35 times. Which letter will be repeated 23 times? That's going to be the letter L. There's one other question that could possibly be asked here, which wasn't, and that could be the total of each column up to a given letter. And so that would be a different type of pattern, and possibly using summation notation and demonstrating how to write some kind of a formulation for that. So this is one demonstration of possible ways to do this. This is really a linear formula, so if you're more familiar with that, which is pretty common for an Algebra 1 course to have linear equations, you could have tried to formulate some kind of linear equation here. You could possibly graph that. This can be graphed as well, and so you can look at a more Algebra 1 type approach to this. But again, things to keep in mind, just because I've solved it this particular way doesn't mean that you could not have solved it another way, and that's something that you need to be open-minded about, that there is more than one way to solve many problems in mathematics. And so when you go to check answers or try to check yourself, you ask a friend, hey, is this what you got? How did you do it? Or I'm stuck at this point, can you explain it? Just keep in mind that they may not have a ready explanation because they may have approached it from another perspective or another angle. We're going to end our video at this point, and you can take a look at some of the practice problems in your own textbook or ones that you come across and try to take on the challenge of how to set up and solve problems.